Okay, I'm going to go ahead and record today's lesson. So if you're not paying attention, you can watch it again later, or because I have some people out in the other class. And our test is on Wednesday. And this is the final unit. So, you have another test, I think?
Yeah.
A theology?
Yeah.
So you pray for one, study for the other. I don't know. Yeah, I just recorded that. All right. Today we're going to be talking about the mathematics of finance. And the reason this is important is you will use this. The number 2 question I'm asked all the time in math is how are we going to use this? And I want to tell you, you will use this. And you need to ask me what the number 1 question was. Where can I use the bathroom? So, and the answer, yeah. Okay. And the reason that the mathematics of finance is so important is because of something called interest. And either you've got money to invest and you're going to earn interest on your money, or you are going to borrow money and you're going to have to pay interest back. And you need to understand what the heck, how it's computed, how are they calculating a particular interest, and what are you going to end up owing. So, some numbers to begin with. Usually in math we use the letter P to stand for the principal. It is the initial amount that you either borrow or invest. It's what your starting value. In math, in this book, they use the letter A to indicate the final amount. So in a way, that's the, I'll just put final amount, and just think of A as being the amount. That's after interest. So it will not be the same as the principal unless you've got a 0% loan or a 0% investment. And I hope yeah, it really is. And some of y'all are going to go on and take econ, right, next semester? You're going to use the same. Yeah, seniors. Well, you will take it then a year from now, or 2 years from now, as the case may be. So you will get that. And of course, the interest is actually composed of 2 items. So 2 items kind of come together to form the interest amount, and that is R, the interest rate, usually given as a percentage, like you earn 5% interest on your investments, or in this day and age, more like 1 or 2%. And if you've got a loan, you pay it out, and if it's a credit card loan, it's through the roof. And then T is for time, how much time. So you apply a 5% interest rate for 4 years, and no problem. And then that determines how much interest. And of course, you would apply this interest to the principal. That would tell you your final amount. Sort of makes sense what we're about to talk about? Okay, 2 kinds of interest we're going to look at. Do you need... I wonder how that sounds when I drop the microphone. Okay. 2 types of interest we want to talk about. Simple and compound. So, we've got simple interest and compound. Both formulas calculate A, what the final amount's going to be, and all the formulas start with some amount of principal. But to figure out how much you get at the end, with simple interest, it is just 1, because you get to keep what you started with, plus whatever the interest rate is times time. This formula actually looks more complicated than it really is.
Can I use a capital R for rate?
You can. They tend to use lowercase r for rate, but you can use capital R if you want. It's whatever you want. We use lowercase t typically. I don't.
It's the initial plus 1. Well, no, the initial times 1 plus 3.
Yeah. So what you're really getting here is principal times 1. It's your initial stuff. And then PRT is really the amount of interest income you've got. Oftentimes you will see it this way. P plus PRT, or PRT tells you how much interest you've earned.
Because that's the interest on your principal.
Exactly. Capital, which that's number 1. That's actually number 1. That's actually number 1. You know, either formula will work. So before we get to compound, let's work a problem, because you can see how this is gonna go, and you'll see this. Let's say you've got $10,000 to invest. So P is $10,000. And don't do what I told my daughter to do 6 years ago. She had saved up $2,000. I said, you don't need it for a while, invest it in the stock market. Stock market promptly went from about 13 or 14,000 down to 7,000 in a matter of months. She lost half of her money in the stock market. Now, it has since bounced back. I didn't let her sell it. I said the stock market will come back, and she's gotten the money back. But if you do invest in something more risky, you've got to go in it for the long haul, because the stock market will fluctuate year to year. In the long term, though, it's giving you a better interest rate than, say, bonds or anything else, treasury notes, anything else you can invest in. So let's assume, though, that you're getting a good investment. R is 5%, and let's say you want to invest it for 4 years. And the question is, how much money will you have after 4 years at 5% a year? Simple interest. Well, you can look at this as 5%, that's the same as 0.05, and if you multiply it times your initial investment, you'll get $500. So every year you expect to make $500.
Will it always say, like, find the simple interest or find the compound?
Yeah, you've got to know what it is. So if you invest in a bank, you want to know, how are you calculating my interest? Most banks use compound, and definitely all credit cards use it. And you'll see how that makes the money grow faster.
So there's interest at the danger money, and there's also interest that you have to pay, correct?
Depends which side you're on. If you're the one who's investing the money, you get the interest. If you're the one who's borrowed the money,
Like for credit card, you're like, do this at 5%.
you're gonna
pay it.
You're gonna pay it. If you do not pay your credit card bill off at the end of every month, they will charge you an interest fee, and it's gonna be higher than 5% typically. It's gonna be more like 10 to 12.
So is this the equation that we're solving, A, would that be just the amount of money you have
After 4 years.
year, or is that the amount of money you have altogether?
Altogether after 4 years, including your initial 10,000.
So,
Right. And you can see if you work the math that it kind of makes sense. You start with $10,000, 1 plus 0.05 times 4. So I'll go into the math. 0.05 times 4. Order of operations says you do the multiplication first. So this becomes 10,000 times 1.2, or $12,000. Now, think about it for a second. If you're getting 5% back, 5% of $10,000 is $500. Just multiply 0.05 times 10,000, you'll get $500. That's your interest. That's what you get every year. 4 years of $500, 4 times 500 is 2,000. That's why the final answer is 12,000. So that's simple interest. Make sense? Questions? So notice that over time, they're still just paying you $500 a year, even though your money kind of has been growing. Because you got 500 the first year, and you got 500 again the second year. What happens to that money? Well, they're just going to pay you $500 every year, and at the end of 4 years, just an even 2,000. So that kind of got to the idea that, is that really fair? Shouldn't you kind of update your current bank account balance more often? And I want to do a simple one. I want to compound this annually and show you kind of how the banks handle your money if you have compound interest. Same example, except I'm going to say compound interest, and I almost have to build up a chart to show you what happens. So I'll put the year here, and I'll put the ending balance, if you will, how much money you've got. And in year 0, you have $10,000, because that's what you start with. At the end of year 1, you earn 5% interest, so you have $10,500. This is the same as you have with simple interest. But now something different happens in year 2. You're going to earn 5% interest, not on $10,000, $10,500. And that may not seem like a big difference, and it's not, But it gets you an extra, instead of $500 interest, it gets you $525 interest. If you do 0.05 times 10,500 on your calculator, you'll see that the answer is $525. So at the end of year two, instead of having just plain $11,000, you've got $11,025. And that's a little fair because in the sense that you just earned $500 interest. If you didn't take that money out of the bank, you should get interest on everything you've got in your bank account. And in this case, it's an extra $25. So now we go to year three, and you do the interest again, and this time, instead of just being 11,500, I think if you do the math on it, you end up with like 11,550 or $57 or something like that. I'm just guessing at the number. But it's going to be more money. And at the end of year four, it's instead of just being $12,000, it's going to be more like $12,080 or $85, somewhere in that range. So you've earned more money because they've updated your bank account more frequently. This is compounding annually, meaning every year they're going to take a look at your bank account, update the current balance, and that's going to be the balance that they determine how much interest you
I
earn.
like that way a lot better than the other one.
Yeah, get you a lot more money.
Yeah.
Now, if you like updating your account every year, how about if we update it every month or every day?
Do people
Or,
do that?
yes. Question.
That's why I like, when I think I always get a letter in the mail and it tells me my like interest amount and stuff I earned for interest and all that stuff.
Yes.
Because it's the annual.
Yeah, well, they're actually updating it, compounding it monthly in your case. So here's what it looks like if you compound more often.
Holy cool.
So I've got some charts here for you. I just did an Excel spreadsheet, and simple interest goes up $500 a year. At the end of 4 years, you're 12,000, 12,500, and if you just kind of go down this column, you can see it just goes up 500 every year. If you start compounding annually, though, you can see that it's going up more quickly. And I didn't update, that's the actual number, where I put 12,080 on the previous sheet, it's actually 12,155. And it's going to go up more quickly, because they're going to update the balances. And at first it doesn't matter a whole lot, but you can see by the time you get down to 15 years into an investment, it's the difference of thousands of dollars. And even more, if you start looking at your bank account every quarter, that means in 3 months, it starts going up even faster. Not a big difference. You can see at the end of this, it's a few $100s more. If you compound it daily, it goes up even faster, but not a big difference. And here is if you were to compound continuously. That's like looking at it every nanosecond and saying, I'm going to update your account. Update, 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 update. And so you'll hear the phrases either compounded daily, compounded continuously, compounded annually. And it's important to know when they say the interest rate is 5%, how's that applied? So in banking terms, what they talk about is the annual percentage rate. Sometimes they